Okay, so before we get into representing amplifiers in a circuit design, I'd like to begin with an example. So over here, we have a microphone, has two inputs, plus and minus, goes into the amplifier box. The amplifier box amplifies it, and then eventually outputs it to a speaker that too has a plus and minus. Okay, so how can I represent this entire thing using circuit diagram? Well, basically it's like this. Okay. So the idea is this microphone over here is gonna produce a voltage difference, an AC voltage difference in most cases, under sound interference. When sound hits the microphone, is going to produce a voltage difference. And what we hope is really this VS being amplified and then out to the speaker. But unfortunately that's not the case, because this microphone has a power loss during the conversion from sound energy into electrical energy, and also as the electrical energy travels through the wire and eventually hits the amplifier. So, how do we represent that? Well, we have a source voltage over here, and we say that all the power loss is going to be resulting from one virtual resistor that we call RS, the source resistance. And we say that if you were to check the two input terminals, which are these two, you're going to have an equivalent source resistance as that value over there. So what's really going to the amplifier is this input voltage, V input. Then the power is going to go into the amplifier. But just like the microphone, the amplifier is also going to have a power loss. And that power loss is going to be resulting from what we're going to call the input resistance, R input. And what happens is that we try to simplify the power loss in the circuit, and so we say, you know what, we're gonna connect just the resistance to the two inputs, and we're gonna say that all the power loss happening at the amplifier is because of this resistance only. Even though in the real world, when you create amplifiers, there's no such thing as a resistance input, because we really do not want this here, because this is gonna cause a power loss. What we really want is that all the power here would be displayed at VI. Because if there is no resistance here, then what we're essentially saying is that there's really no current going through that microphone or that light sensor or whatever. And so if there's no current going in, then how can we assume that there's a voltage drop across RS? So to assume that there's a voltage drop across RS, we have to have some kind of closed circuit, and we're going to call the input resistance, and that all the voltage drops is caused by here. But ideally, we do not want this to exist. Then what's going to happen is going to see the voltage at this point. If it's an AC signal, a sinusoidal signal, then we're gonna produce that output over here. But we want to amplify. We want it much more than how the input is, because the microphone is going to produce a very small, like a millivolts or maybe even less of a voltage difference. And so we want to amplify it to the volts so that we can power the speaker. So what we're saying is we're going to have a voltage controlled voltage source. In other words, the voltage at these two inputs is going to control the voltage at these two inputs, except that this voltage source will just multiply by a gain, and usually we call that A. So this voltage source, the value of this is going to be A VI. So some gain, usually like 1,000,000 times, and then whatever the input happens to be. And then we're going to have a resistance here. This is just the same as this kind of resistance. When the voltage produced goes out, there will be another voltage drop occurring at the amplifier, because electricity going through a wire is going to lose some power, even if it's going to be very little. And as you can see in this case, we do want no power loss, so it's supposed to be 0. But we're going to call this R out. Now this voltage V out is the voltage over here if the amplifier is not connected to the speaker. And so what we call this is an open loop gain. In other words, we're taking this input over here and we're going to gain it and have the output. Because gain is defined as V out over V in. And V out will equal to this power if there's no current going through, so that our output will not lose any power. But once we connect the speaker over here, we're going to have a load attached to it. And once we attach a load, we're creating current. And once current goes through, by Ohm's law, there'll be a voltage drop at the resistance, and so power will be lost. And so ideally what we hope is that this resistance is 0, and that this resistance is infinity. Although we can easily say that we wouldn't care about these two resistors and say, you know what, maybe this one becomes 0. But because it's impractical to make this 0, because the device that you're purchasing comes with a resistance, what we really talk about is these two, changing these two values. We want our amplifier to have these two values respective to each other. In other words, Ri to be infinity and Ro to be 0, so that we can have very efficient energy transfer between the two. And so we have our load resistance over here, which is caused by the speaker, and if this is 0, we're going to have all the voltage drop across here, which means 100% power transfer. And so this is basically the design of the basic introductory amplifier circuit. When you move on into op amps and other kind of amplifiers, then it will be a little bit different, but the basic idea remains the same.